Good morning, everyone. Let us start this session. So in the today's session, we will discuss about the wedge friction. So this is the second type of friction problem. During the last few lectures, we have studied the block friction and we have solved the problem on the equilibrium of the blocks. So what is meaning of wedge? So wedge is the tapered member or tapered block which is used to lift the heavy load by applying relatively small effort. So wedge, it is the tapered member or tapered block. So it is used to lift or slide the heavy weight by applying relatively small effort. Okay, that means if you apply the small force on the wedge, you can lift the heavy load. So it is used to lift the heavy objects or heavy machines. So it is used to lift heavy machines by small distance. So this is the general shape for the wedge. So if you consider the rectangular object like this, okay, and if you cut this object along this line, then you can see the wedge shape. Okay, so this is the wedge shape. So here I have drawn this shaded region. Okay, so in 3 dimensions, so this is the wedge member or the wedge block. So what is the use of such tapered member? So here you can see one arrangement. So I have shown one heavy object which is to be lifted in the upward direction. So we want to move this object in this direction, okay, by very small distance. So let us take the weight of this object which is acting exactly in the downward direction, okay, and here we have shown the wedge arrangement, okay. So here we have the wedge A and wedge B. So if you apply the horizontal force on this wedge B in this direction, let us take this force to be P, okay, then the wedge A, it will move in the upward direction, okay, because at this contact between the wedge A and wedge B, there is a relative motion, okay. So when we apply the force P, the tendency of the wedge B to slide in the leftward direction, okay, and at the same time the wedge A, it will have the motion like this. So relative to B, the wedge A, it will slide on the rightward direction, okay, and along this vertical wall there is also sliding motion. So this is the contact surface, okay. So wedge A, it will move in the upward direction relative to this vertical wall, okay, and then this wedge A will offer the reaction on this heavy object or heavy machine, okay. and then you can see the motion in the upward direction. So this arrangement, it is generally used in order to lift the heavy load in the industry. So I will show one simulation, then you can understand the exact use of this wedge arrangement. Okay, so I have shared one software screen. So here you can see there is one wedge arrangement. This is the wedge B, this is the wedge A, okay? And this is the heavy machine part, which is to be lifted by very small distance, exactly in the upward direction, okay? So for that, we will apply the force on this wedge, okay, in the negative x direction or in the leftward direction. Because of that, this wedge, it will slide on this wedge, okay. At the same time, this wedge, which is the wedge A, it will slide on this vertical wall, okay, and then it will lift the heavy load. So you can see this motion. Just I will play this simulation. So observe the movement of this block, okay, at the same time movement of this wedge B. So this is the force. So you can see here, gradually this wedge is moving on the left side, and this wedge, it is moving in the upward direction. Okay, just I will zoom this. Okay, now again observe this point, this corner point. So you can see the motion with the black line, which is in the upward direction. So you can see here, this black line is the upward direction movement. So here, if you observe the movement of this block relative to this block, okay, then it is on the right side. So again, I will play the simulation. So as this block is moving on the left side, this block is moving on the right side, which is relative to this block. Okay, so this is the application of the wedge. So with the help of this wedge hydraulic jack, we can lift the heavy machine by very small distance. Okay, and then we can position the base of that machine exactly in the horizontal plane. So this is how we can connect this wedge jack to the base of the machine, and we can lift the base by very small distance. So you can see here the sliding motion of the wedge. And after this, we can lift the machine to a desired height. So observe this movement of the wedge. Okay, so this is the application of the wedge. Okay, so I hope the concept is clear. What is the use of wedge? So now we will solve the equilibrium problem on the wedge friction. A block of 150 kg is raised by 10-degree wedge which is having the weight 50 kg, and by applying a horizontal force which is a P. So coefficient of friction between all the contact surfaces is 0.3. So mu, that is a static friction, this is equal to 0.3, and it is for all contact surface. Find the minimum force P to be applied to raise the block. So find the value of P. Okay. So the wedge arrangement, so this is the heavy block which is to be lifted. So this block, it is having the weight 150 kg. Okay, so we need to multiply this by 9.81 so that it will be in Newton. Now 150 kg, it is just a mass. So here M for the block, this is equal to 150 kg. So W, it will become 150 into 9.81 Newton. Next, there is a wedge arrangement. So actually this block is slightly tapered, and then we have the wedge. Like this. Okay, so this wedge, it is having the angle 10 degree. Okay, so 10 degree means so if this is the wedge, okay, so if you extend this line, then this angle, this is nothing but the angle of the wedge, and right now it is given as a 10 degree. Okay, so similarly here, this angle, this is 10 degree, which is the wedge angle, and the coefficient of friction for all the contact surface is 0.3, and we have to find out the external force, which is the horizontal force P on the wedge, so that this motion of the block, it will be in the upward direction. Okay, So to solve such problem, that is on the wedge friction, your first step will be we have to draw the free body diagram. So draw the free body diagram. So isolate this block from the wedge and from this vertical wall. Okay. And then show all the forces and the reactions acting on the block. So the first force on this block, it is the self weight, which will act exactly in the downward direction. So this is equal to W, and this is 150 into 9.8 Newton. Then second force, observe the contact surfaces. So this block, it is having two contact surface. One is contact surface between the wedge and the block, and second contact surface is between the block and the vertical wall. Okay. So each contact surface will offer one normal reaction. So at this contact surface, there is one normal reaction. It will be like this, which is exactly perpendicular to the contact surface. So this normal reaction I will consider as a N1. So what is meaning of N1 is the vertical wall will offer one reaction on this block. So in the free body diagram, this normal reaction will be exactly horizontal, or it is exactly perpendicular to this vertical line. So this normal reaction is N1. Second normal reaction will be at this contact surface between the wedge and the block. And this normal reaction will be like this. So let us take this normal reaction as a N2, and this N2 will be perpendicular to this contact surface. Now this N2 reaction, it is the common reaction for the block and the wedge. So in this problem, we will draw the free body diagram, one for block and second free body diagram, it is for this wedge. So for the wedge, this N2, it will be common reaction. So N2 will be exactly opposite when you consider the free body diagram for the wedge. And it is also perpendicular to this surface. Okay, so N2 is same. Then for the wedge, its weight is given, which is 50 kg. So it will act from this point exactly in the downward direction. So this is equal to 50 into 9.81. Then there is an external force P, which is to be determined. So this is the P force. So here we have shown normal reaction and the self weight. Now we have to consider the impending motion. So when we consider the impending motion, then we have to consider the friction force. So when we apply the force P on this wedge on the leftward side, the motion of this wedge definitely it is on this side in the same direction of the force P. So impending motion for this wedge, it will be on the negative x direction. So we have to show the direction for the impending motion so that we can decide the friction force. So this is your impending motion. So this impending motion, it is for this wedge only. Now for the wedge, there are two contact surfaces. This contact surface, and there is another contact surface between the wedge and the ground. So this is the ground. So this is your second contact surface. So there will be a normal reaction at this contact surface between the wedge and the ground. So this is the normal reaction N3. So here we will show the normal reaction N3. Now let us decide the direction of the friction force. So observe the impending motion. So friction will be exactly opposite to the impending motion. So at this contact surface, we will show the friction force like this. Okay, and this friction, its equation F is equal to mu into normal reaction. So actually this is a F max, which is called as a limiting friction force. So coefficient of static friction into normal reaction. So now it is N3. So this is equal to 0.3 into N3. Again, at this contact surface, there will be friction force and it is along this plane. So we will show that friction force like this, which is along the plane. And this friction force, this is equal to friction is 0.3 and normal reaction is N2. Okay, so both these friction forces, they are acting exactly in the opposite direction to the impending motion. Now consider the consider the block. So for the block, at this contact surface, there will be friction force, but we have to observe what is the direction of the impending motion. So just observe this diagram. So when we push the block, that is a wedge, on the left side, then its motion is on the left side. But this block, its motion will be, for this contact surface, it will slide in this direction relative to wedge. And this contact surface, it will slide in this direction. So for this contact surface, its impending motion will be like this. So actually we are considering the relative motion. So this is the impending motion. And the friction will be exactly opposite to the relative motion or impending motion. So we will show the friction like this, exactly in the opposite direction. So this is your impending motion direction and this is the friction. So this friction and this friction will be same. Exactly, magnitude will be same, but direction is opposite. So this is equal to 0.3 into normal reaction is N2. Because it is the same contact surface. Now observe the contact surface, which is the vertical one. So impending motion for this vertical surface is in the upward direction. So friction will be exactly in the downward direction. And this value is 0.3 into normal reaction is N1. Okay, so this is your complete free body diagram for the wedge and the block. So after this, we will use the condition of equilibrium to find out the P force. So which free body diagram we should consider first? So observe the free body diagram for the block and find out the total unknowns. So here we have unknown N1 and N2. So only two unknowns. But if you observe the free body diagram for the wedge, then we have three unknowns. N3, then this common N2, and third is the P force. So for this block friction, we only have the two conditions of equilibrium. One is summation Fx0 and second condition is summation Fy0. Third condition, which is summation of moment 0, we cannot use this condition. So when we can use the summation of moment condition, if there is a possibility of rotation. So if you observe this free body diagram or complete system, then there is no tendency of the rotation. So we cannot use the third condition. So available conditions for the equilibrium, one is summation fx0 and summation fy0. So select the free body diagram having only two unknowns. So we have to select the block first. So consider the block free body diagram and then use the condition of equilibrium. So by using the conditions of equilibrium, so first I will use summation fx0. Now write the summation fx. So for the summation fx, just observe the inclined force. So I will assume this direction as a y direction and this is your x direction. So if you observe this force 0.3 n1, it is along y direction, w along y direction, n1 so n1 is along x direction, but this n2 force and this force 0.3 n2, they are not along this x direction. So we have to resolve these forces. So for that, just I will select this point, then draw one component which is parallel to this x line, second component parallel to y line. Similarly, resolve this 0.3 n2. So draw one component which is parallel to x like this and second parallel to y. Okay, now we have to find out what is the angle. So for that, observe this geometry. So this angle is given. This is 30 degree. Okay. So similarly, if you draw one line, then this angle, it will be same. This is equal to 10 degree. Okay. So as this angle is 10 degree, that means this angle, this is also 10 degree. So this is 10 degree. So x component of this 0.3 n2. So this will be, just I will draw the separate free body diagram. So this is the weight W, which is a 150 into 9.81. Then this is the normal reaction, which is offered by a vertical wall, which is a N1. Then this is the friction force at this contact surface between wall and the block. So this is 0.3 into N1. Then at this contact surface, there is a perpendicular normal reaction, which is offered by the wedge. And this is a N2. It is a common reaction. It is perpendicular here. Then at this contact surface, there is a friction force along this plane, and this is the direction. Okay. So we will resolve these two forces. So this is our reference axis. So remaining forces, they are exactly along this x and y direction, but these two forces, so this is 0.3 n2. So we have to resolve that two forces. So I will select n2. Draw one vector which is parallel to x axis. Draw a second vector parallel to y axis. So you can see here for the wedge, this angle is given as a 10 degree. So this angle, it will become the alternate angle. So it is a 10 degree. So this component, it will become the adjacent component. So this is equal to your net force is 0.3 into. So this component will be 0.3 into cos of 10 degree. So this is a cos 10. The y component is the opposite component. So its magnitude will be 0.3 into sin 10. Okay, so this is the resolution for this friction force. Next, we have to resolve the normal reaction. So you can observe here, as this angle is 10 degree. So this small angle, it will become 10 degree. Okay, so even you can find out this angle by some construction. So I will directly take this angle as a 10 degree. So this component is the adjacent component. So it will become n2 cos 10. And this component is the opposite component. So it becomes n2 sin 10. So this is complete resolution. Now write the summation fx 0, which is the first condition of equilibrium. Consider all x component starting from this n. n1 is positive. Then we have this n2 sin 10 on the negative side. So minus n2 sin 10. Then we have this 0.3 n2 cos 10 again on negative side. So 0.3 n2 cos 10. Okay, so only 3 component along the x direction. So this is equal to 0. So from this, just take the common n2 and find out the value of its coefficient. Now use the condition summation fy0